Hello everyone. On this video we will be looking at some characteristics of parabolas. Okay, so the equation of a parabola, well, not the equation because we don't have an equal sign, but the expression of a parabola just has the form of ax squared plus bx plus c, where a, b, and c are constants and a does not equal 0. Okay, now the vertex in this case is the maximum value whenever that a is less than 0. Okay, so in other words, you have, let's say for example, negative 2x squared plus 4x plus 5. We can tell just by the fact that that a is equal to negative 2 that this parabola is going to open downward. Okay, and we know that the vertex is going to be the maximum value. Okay, now when your a is greater than 0, then you know your vertex is going to be the minimum value, because whenever your a is positive, your vertex will appear on the bottom, which is the lowest possible value. Okay, so for example, if you had 3x squared plus x plus 8, we know that this would open upward. Okay, so you know you have your ax squared plus bx plus c. On this example, your a is equal to negative 2, your b is equal to 4, and your c is equal to 5. In this example, your a is equal to 3. When there's no constant next to your variable, it's a 1. You assume it's a 1. So whenever you just have x, it's the same as saying 1x. So you have x, let's say your b is equal to 1, and your c is equal to 8. Okay, so this would have been minus 8, then your c would have been negative 8. But because this is plus 8, then your c is positive 8. Okay, now to find the actual point of your vertex, all you have to do is plug in your a and your b's into these two equations. Okay, to find your x value, you plug in negative whatever your b is and divide it by 2 times whatever your a is. And we'll do a few examples of those. And to find your y value, you just take your x value after plugging in your b and your a's and plug that into your original equation. Okay, and just a quick review, I'm going to slide that up. To find your x-intercepts, you make your y equals 0, or in some cases your f of x equals 0. And to find your y-intercept, you just make your x equals 0. Okay, and we have one more term, and that's called the axis of symmetry. The axis of symmetry is literally just the x value of your vertex. So if you solve for your vertex here, that's your axis of symmetry. That's because if you have your vertex, and let's say this is at point xy, if you get fat and you chop your parabola right down the middle, there should be a mirror image on each side. It should be symmetric on both sides. That's why it's called the axis of symmetry. All right. So if you are still writing, of course, feel free to press pause and finish up. We're going to go ahead and move on to our next page, which is our first example. Let me move that down. Okay, so for f of x equals 2x squared minus 4x minus 1, find the vertex, the minimum and maximum values, and the axis of symmetry. Okay, now here's a hint. You have f of x equals 2x squared minus 4x minus 1. Your a is equal to 2. Your b is equal to negative 4. Your c is equal to negative 1. Okay, so use the information on the previous page, press pause, and try this one on your own. Alright, so I'm assuming you've already pressed pause and worked this one out. So let's go ahead and verify your answer. Okay, so we know for our vertex, our x value is negative b divided by 2a. Okay, so that's going to equal negative, your b is negative 4, so that's negative 4 divided by 2 times 2. So negative times negative is positive, so that's 4 over 4, which is 1. So that's your x value. Now for your y value, we get your x value and plug it in. Okay, so in other words, let me move that over a little bit. So your y, remember y is equal to f of x. And your f of x, we know that's 2x squared minus 4x minus 1. Okay, so to find our y value for our vertex, we plug in the x value of our vertex. So in this case, that's f of 1, which will equal 2 times 1 squared minus 4 times 1 minus 1. Okay, so 1 squared is 1, so you have 2 minus 4, which is negative 2, minus 1, which is negative 3. Okay, so your vertex is equal to your x value and your y value here, which is 1 and negative 3. Okay. Now, the thing is, we don't have to do any more to find our axis of symmetry. It's the x value of our vertex. So x equals 1 is our axis of symmetry. Okay. And also, to find our minimum and maximum value, we can also use our vertex. Okay. So we see here, let me draw a little arrow up to that negative 3. So we know that since 2x squared minus 4x minus 1, we know here that our a is greater than 0. Uh-oh, sorry about that. All right, so we see here that our a is greater than 0. Now, since a is greater than 0, we know that our parabola is going to open upward. So that means f of x equals negative 3 is our minimum value. Okay, so we were able to find our vertex, our axis of symmetry, and our minimum value. So really, if you look at it, the vertex will tell you both the axis of symmetry and the minimum value. Okay. Now, if you had a negative 2x squared here, then it would open downward, and that would be our maximum value. Because in this case, our vertex is down here, our minimum value. All right. So if you are still writing, feel free to press pause. We're going to go ahead and move on to the next page. Okay. So one thing we know, which you just saw, that we can find the vertex using negative b divided by 2a to find our x value, then plugging that x value into our function to find our y value when it's in this form. Okay, that's the standard form. Now, if we complete the square of our standard form, we can actually get an equation in our quadratic form. Okay, in our quadratic form, this is standard form. Okay, so you have f of x equals a times x minus h squared plus k. Okay, so we know here that our h and our k is the vertex. And when it's in this form, the h value is our axis of symmetry. Okay, so it's a little bit different when it's in this form as opposed to the other form. Okay, so once again, the things that don't change is the fact that when a is greater than 0, our graph will open upward, and our vertex will be our minimum. And we know that when a is less than 0, our graph will open downward, and our vertex will be our maximum. That's the same no matter which form it's in. All right, now we're going to look at how to convert from one to the other. But first, we're going to take a quick glance at the proof. Now, you don't have to know the proof or memorize it or recite it or anything like that. It's just one of those things that we put out there to show you that these equations don't just pop up. They actually have some basis. So every once in a while, I'll prove an equation just to show that, okay, no one just pulled this out of thin air. There's an actual process as to how this equation came about. Okay, so let's say we have f of x equals ax squared plus bx plus c, and we want to show that that's equal to a times x minus h squared plus k. Okay, so what if we start off with our f of x equals ax squared plus bx plus c, and we subtract c from both sides. Okay, so we subtracted c from both sides, and we ended up here because c minus c is 0, so that vanishes. So we end up with c here. Okay, so what if we factor out an a from both of these equations? Both of these terms. Okay, well, there's no a here, but if you look over here, what we did, we multiplied this by a over a. So we were able to factor an a out of this. So if we factor an a out of this, we are left with x squared plus b over a times x. Now, just for the parentheses part, we're going to complete the square. Okay, so we know to complete the square, it's b divided by 2a squared. So we distribute that, we have b squared over 2a squared, which ends up being 4a squared. And we're going to add this to both sides. Okay, so if we add this to this side, just inside the parentheses, we have x squared plus b over ax plus b squared over 4a squared. Okay, now on the left side, we have to adjust because remember, when you distribute this a, you will have a times b squared over 4a squared. So that's what we have to have on this side, a times b squared over 4a squared, just to account for that distribution of the a right here. Okay, now on this left side, the a's will cancel out. Well, at least one of the a's will cancel out in the denominator here, and this a right there. So we will have f of x minus c plus b squared over 4a. And this is actually a perfect square trinomial. So this will factor into a times x minus b over 2a squared. All right, so just going to go ahead and move up. So now, once we have this, we're going to combine these two terms by multiplying it by 4a over 4a. So we have f of x minus 4ac over 4a. Because remember, if we cancel out the 4a's, we get our minus c. Plus b squared over 4a equals a times x minus b over 2a squared. And we're going to go ahead and solve for f of x. Okay, so if we subtract 4ac from both sides, and, well, we add 4ac and subtract b squared over 4a, we get f of x equals a times x plus b over 2a squared minus b squared over 4a plus 4ac over 4a. Okay, so we go ahead and combine these two because they have common denominators. So we have f of x equals a times x plus b over 2a squared plus 4ac minus b squared over 4a. All right, so if you're still writing, feel free to pause it, but we're going to go ahead and finish this up on the next page. Okay, so this is where we left off. Okay, so remember the vertex has the point negative b over 2a and f of negative b over 2a, which is hk. So here, since we have x plus b over 2a, we make that x minus negative b over 2a. So we have a times x minus negative b over 2a plus 4ac minus b squared over 4a. So our h is our negative b over 2a, which is the x value of our vertex, and our k is 4ac minus b squared over 4a. You don't have to remember that to solve the equations or anything in the future, but it's one of those things that are helpful with the proof. We just assign that as a value of k. So we have f of x equals a x minus h plus k. Okay. Now the thing is, how do we know that this is equal to k? Well, all we do is we plug in our f of negative b over 2a. So we have f of negative b over 2a equals a times negative b over 2a squared plus b times negative b over 2a plus c. Okay, so this, if you distribute the square, you have b squared over 4a squared. Negative times negative is positive, so that becomes positive. And one of the a's cancels out. So you have b squared over 4a minus b squared over 2a plus c. Now we get all of them with the same denominator. So you have b squared over 4a minus, we multiply this by 2 over 2. We get 2b squared over 4a plus, we multiply this c by 4a over 4a. We get 4ac over 4a. And we go ahead and put all of those over the same denominator after we combine these two. So you have negative b squared plus 4ac all over 4a. Oh, b squared. Oh, this should be b squared minus. Well, no, negative b squared, because you get minus b squared minus 2b is negative b squared plus 4ac. Then we just go ahead and switch those around. So we have 4ac minus b squared over 4a, which is our k value. So again, you don't have to do all of this to solve the problems. This is just a proof to show that the equations came from somewhere. All right. So if you are still writing, of course, feel free to press pause, but we're going to go ahead and move on to our next example. All right. Now, let's say you have f of x equals 2 times x minus 3 squared minus 4. And we want to identify the vertex and axis of symmetry. Okay, so hint, remember, this is in this form. So you want to, well, let me go back to the page. You want to go back to, I'm going to cover this up for a second, to this page here. Okay, so this is what you're going to use to answer that question. All right, so I want you to go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and you've already worked this one out. So let's go ahead and verify. Okay, so we know that f of x equals a times x minus h squared plus k. So what we're going to do is we're going to put this right up under this and match everything up. Okay, so we know that f of x equals 2 times x minus 3 squared minus 4. Okay, now here we see that our a is equal to 2. We have x minus h, so this is x minus 3. So our h is equal to 3. And this one, this has to be plus k. Okay, so what we're going to do is we're not going to change anything, but we're going to make this plus negative 4. Okay, so instead of minus 4, we just made it plus negative 4. Okay, because remember, all of your signs have to match. So you can't have different signs in both forms, because if you just put that k is equal to 4, this wouldn't have been correct. Okay, but it is correct that k is equal to negative 4. So we know that a is equal to 2 h is equal to 3, and k is equal to negative 4. Okay, so our vertex, which is hk, is actually 3, negative 4. And our axis of symmetry is still our x equals 3. It's still the x value of our vertex. All right. So if you're still writing, feel free to press pause. We're going to go ahead and do another example. And in this example, we're going to convert f of x equals 2 times x minus 3 squared minus 4 to the f of x equals ax squared plus bx plus c form. Okay. Now I'll give you a hint. You want to expand the x minus 3 squared, which means you want to make it x minus 3 times x minus 3 and then FOIL method. All right. So when you go ahead and press pause and try this one on your own. Excuse me. All right, so I'm assuming you've pressed pause, so let's go ahead and verify your answer. Okay, so you have f of x, forgot my f of x. F of x equals 2 times x minus 3 squared minus 4. So we're going to go ahead and expand that part. So you have 2 times x minus 3 times x minus 3 minus 4. And then we're going to go ahead and FOIL these two factors. Okay, so this gives us 2 times x minus 3. So our first is x times x, which is x squared. Our outer is negative 3, and negative 3x, and our inner is negative 3x. So that gives us negative 6x. And our last is negative 3 times negative 3, which is positive 9. And that's minus 4. Okay, so don't forget your parentheses, because this is 2 times this whole thing. So this should be 2 times this whole thing. So those parentheses are very important. Okay, so we go ahead and we distribute our 2. So you have 2x squared minus 12x plus 18 minus 4. Excuse me. Okay, so we combine our constants. So we end up with 2x squared minus 12x plus 14. Okay, so we know that f of x equals 2 times x minus 3 squared minus 4 is also equal to 2x squared minus 12x plus 14. Okay, same expression, just in different forms. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. And on this example, we're going to rewrite f of x equals 4x squared minus 16x plus 17 in standard form, which is a times x minus h squared plus k. Okay. Now, hint, you want to complete the square of those two terms, but you want to factor out the 4 first. All right. So we're going to go ahead and I want you to press pause and try this one on your own. All right. So I'm assuming you've paused it and worked it out. So let's go ahead and verify. Okay, so the first thing you should have done, factor out the greatest common constant, not factor, from the two x terms. Okay, so in other words, if you have 4x squared minus 16x plus 17, you're going to factor out the greatest constant from those two x terms, which in this case is 4. So you can factor 4 out of both of those. So you have, let me put my f of x equals, okay, so if you factor out a 4, that leaves you with 4 times x squared minus 4x. And what we're going to do is we're going to leave a little bit of space after that. So we're going to leave a little space after that and then put the plus 17. Okay. So this is where we do our completing the square. All right, so go from here to here. So you have 4, I'm just going to rewrite it, x squared minus 4x plus some value plus 17. Okay, so we see here that our a is equal to 1. We see here that our b is equal to negative 4. So we're going to do our completing the square right here on the side. So our completing the square is equal to negative b over 2a squared. Okay, so that's going to equal negative 4 over 2 times 1 squared. Okay, so negative times negative is positive, so you get positive 4. Oh, that's not negative. I'm thinking of the vertex. This is just b over 2a squared. There we go. Okay, so for completing the square, you have negative 4 divided by 2, which is negative 2 squared. And that's equal to 4. Okay, so you want to remember this, that negative 2. And I'll show you why. Okay, so going back here, because remember this is what we did here, that's equal to 4 times x squared minus 4x minus, or plus 4, plus, okay, now remember here, we added 4 inside of here. So if we distributed this 4 here, this would be 16. So we'd have 4x squared minus 4x plus 16. I mean minus 16x plus 16. So we can't have that. Okay, so you have the 4x squared minus 16x plus 16. To balance it out, you have to subtract 16. Okay, because you can't just add a value in here. It has to balance out. So if you have the 4x squared minus 16x plus 16 minus 16, you technically just added 0. So it didn't change the expression much. It just changed the shape of the form. Okay, and then you can't forget your plus 17. Okay, now remember this right here is now a perfect, let me move this up, perfect square trinomial. All right, so that means you have 4, and remember I told you remember this value, because this value before you apply the square is what goes here. So you have x minus 2 squared, and then you combine these two and you get plus 1. Okay, so if you get this and you expand and distribute and all of that, you will end up right back here. So these two are equal, just different forms. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and do another example. Okay, so this is pretty similar to the one we just did. We want to convert f of x equals 2x squared minus 12x plus 14 to f of x equals a times x minus h squared plus k form. Okay, so just like we did on the previous page, but I want you to go ahead and press pause and try this one on your own. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify. Okay, so we have f of x equals 2x squared minus 12x plus 14. Okay, so if you did everything correctly, you know that you now factor out the greatest common constant. So here we factor out a 2. So that's going to equal 2 times x squared minus 6x plus 14. And for inside the parentheses, we complete the square. Okay, so we're going to go ahead and rewrite that. So it's 2 times x squared minus 6x. And we're going to leave a space available here, plus 14. Okay, so once again, we know that our a is equal to 1, and our b is equal to negative 6. So we're going to go ahead and complete the square on the side here. So complete the square equals b divided by 2a squared. Okay, so that's going to equal negative 6 divided by 2 times 1 squared. Okay, so that's equal negative 6 divided by 2 is negative 3, so you have negative 3 squared. And you want to remember that. Negative 3 squared is equal to 9. Okay, so this is the value we're going to add and subtract, basically. Okay, so you have 2 times x squared minus 6x plus 9. But remember, you distribute this 2x squared minus 12x plus 18. We can't just throw 18 in there. So you have that plus 18. That means we have to have a minus 18 to balance it out. And we still have our plus 14 that we bring down from up here. Okay, so remember, whenever you add, complete the square, and you add that value, always think back, okay, if I distribute this coefficient here, what value did that give me? And if it gives you, in this case, a positive 18, you have to subtract an 18. Because the whole point is to not change the value or add anything to it. You're just changing the form. So when you add 18 and subtract 18, it's 0. So you basically added 0. Okay, so this is going to equal, oh, forgot to tell you, this is your perfect square trinomial. Move that up a little bit. Okay, and remember that negative 3 here. This shows this is 2 times x minus 3. Don't forget your squared. And then we're going to combine these two, which is minus 4. So we know that this is equal to this. It's just a different form. So again, if you get x minus 3 squared and FOIL it out and then multiply 2 to each term and combine your like terms, you will end up with this. All right. So if you are still writing, feel free to press pause. But we're going to look at a few graphs. Okay. And from those graphs, we are going to come up with our entire equation. Okay. So for this one, we want to determine the equation of the parabola just using the graph. Okay. So looking at this graph, we're going to come up with our whole equation. All right. So here we're going to look at the x and y intercepts. Okay. X and y intercepts. Okay. So first thing we're going to notice, well, not notice, but remember, is that ax squared plus bx plus c is the same as a times x minus h squared plus k. All right. So the second thing we're going to do, we're going to notice the x-intercepts, x and y-intercept. X-intercept is equal to -2, 0. And 1, 0. Okay, so -2, 0, and 1, 0. Those are your x-intercepts. Okay, so in other words, when x equals, well, when y equals 0, rather, x equals -2, or x equals 1. Okay. Now, the third thing you're going to look at is kind of temporarily ignoring the k. We're going to see that y equals a x minus h squared. So this could be x minus or plus something. X minus or plus something. Okay. So we know here that plugging in x equals -2 or x equals 1 will give us y equals 0. So what we have to do is, if we plug in x equals -2 or x equals -1, we know if we plug in +2, just change the sign, and we plug in -2, that'll make this whole thing 0. And here if you have 1, so if you plug in a -1 or -1, so you plug in 1 here, you have 1 minus 1, which is 0, which turns all of that 0. Okay, so remember, plugging in x equals -2 or x equals 1 makes y equals 0. Okay. Okay. Now, after that, oh, sorry about that. Now, for your fourth step, we're going to use the y-intercept to solve for our a, because we still have our a here. Okay, so we know that the y-intercept, let's move that up a little, there we go, is right here. So that's 0, -2. Okay, so when x equals 0, y is equal to -2. When x equals 0, y equals -2. All right, so we're going to use this equation here. So y equals a times x plus 2 times x minus 2. Okay. So using this here, when x is equal to 0, y is equal to -2. So we have -2 equals a times 0 plus 2, 0 minus 2. Okay, so all we did was make x equals 0 and y equal -2. Okay, so we know that x equals 0, if we simplify that, we have -2 equals a times 0 plus 2, which is 2, times 0 minus 2, which is -2. Oh, 0 minus, x minus 1. Sorry about that. I knew something didn't look right. There we go. There's 1 and 1. Yeah, sorry about that. All right, so 2 times -1 is -2. So that gives us -2 equals a times -2. Divide both sides by -2. We have a equals 1. Okay, so if a equals 1, we just get this, and we replace a with 1. So y equals 1 times x plus 2 times x minus 1. Okay, so if we go ahead and FOIL this out, that gives us y equals x squared plus x minus 2. Okay, so we know that this graph, just based off the graph alone, is y equals x squared plus x minus 2. And I'll bring this up a little bit more if you're still writing. Okay. All right. So that's how you find out the graph just from, or find out the equation of the graph just from looking at it. All right. So if you are still writing, feel free to press pause. But we're going to go ahead into the next example, where on this one we use the x and y intercept. On the next example, we're going to use the vertex. All right. So method 2, use any point and the vertex. Okay. Now, no one method is better than the other. It's just a matter of when they give you the x and y intercepts here, you see the x and y intercepts aren't like perfectly on a -2 or -1. They're somewhere in between, so you can't be confident where the x-intercepts are. So whenever you have one like this and you don't know where the x-intercepts are, you want to use this method. Okay, so once again, it starts the same way as before. The first step is you want to remember ax squared plus bx plus c is equal to a times x minus h squared plus k. Okay, but on this one, instead of the x and y intercepts, we're going to notice that the vertex is at -3, 4. Okay, well, what does that tell us? Well, that tells us that in this form, we can make y equals a times x minus -3, because remember, this is your h, and this is your k. So x minus -3 squared plus 4, or we can make that y equals a times x plus 3 squared plus 4. Okay, now, before we could use the x and y intercepts and all that good stuff, but since the intercepts are not clear, use any point on the graph. Use any point on the graph to solve for our unknown a. Okay. Now, if you notice here, one of the points that actually is pretty clear is -2, 2. Okay, we know that's right there on the graph. Okay, so as long as you can look at the point and go, okay, this is right smack on the graph, we can use it. So we can use -2, 2. So we use -2, 2. That is on the graph. Okay, so what this tells us is that when x equals -2, y equals 2. Okay, that's really all that point tells us. Okay, so when we know that, what do? We plug it in. We have y equals a times x plus 3 squared plus 4. And that becomes, when x is equal to -2, y is equal to 2. So we go ahead and replace our y's and our x's with -2 and 2. So we have 2 equals a times -2 plus 3 squared plus 4. Okay, so all we did was replace our x and y's with -2 and 2. Okay, so that gives us 2 equals a. 2 plus 3 is 1, so 1 squared is just 1 plus 4. So if we subtract 4 from both sides, we get 1a equals -2, or just a equals -2. Okay, so we go back and we plug this in. Y equals -2 times x plus 3 squared plus 4. Okay. Now if we wanted to, we can leave it in this one. So instead of y, we're going to make that f of x, just to keep it consistent. Because remember, y is just equal to f of x. Okay, so you can leave it in this form, or you can make it f of x equals -2 times x plus 3 times x plus 3 plus 4. So if we go ahead and FOIL these two, it would be -2 times x squared plus 6x plus 9 plus 4. So if we go ahead and distribute our 2 and bring that up a little bit more, it's going to equal -2x squared minus 12x minus 18 plus our 4. Okay, which is equal to -2x squared minus 12x minus 14. Okay, so either one of these would be correct. It just depends on which form that particular question wants you to put it in. Okay, and they'll usually tell you put it in ax squared plus bx plus c form, or put it in a times x minus h plus k form. All right. So hopefully this made sense, and I will see you on the next video.